This aerial view of the Bundibugyo district in Uganda shows the isolation that defined the region before August 2007. Located on the Congo border, it was a landscape of deep tropical rainforests and small, self-contained villages. For villagers like Agnes, a local mother of two, the boundary between human settlement and the deep jungle was almost invisible. Daily life happened right at the edge of an undocumented ecosystem. That quiet was broken when a man arrived at a local clinic with a severe fever, a headache, and intense body aches. Because these symptoms mirror malaria and typhoid, both common in the area, doctors provided standard medication and sent him home. This similarity to common local diseases allowed the pathogen to cross the village's only medical checkpoint without being identified. The standard treatments failed. Within days, the man's family fell ill, followed by their neighbors. The illness began jumping rapidly from house to house. The symptoms soon escalated. Patients began suffering from internal hemorrhaging and red eyes, while severe rashes and systematic organ failure replaced the initial fevers. Local doctors grew concerned as the physical deterioration began to resemble Ebola. However, when they ran the standard diagnostic tests for known Ebola strains, the results came back negative. They were watching a lethal, fast-spreading disease wipe out their community, one that modern medicine could not yet identify, cure, or categorize. The crisis triggered an international response. Specialists from the WHO and CDC arrived in Uganda to establish these fenced perimeters, physically sealing the village to trap the pathogen. Inside sealed labs, researchers in positive pressure suits began the process of extracting the pathogen from patient samples to determine its genetic structure. This diagram shows the Filovirus family tree. Before 2007, science recognized only 4 species within the Ebola branch: Zaire, Sudan, Reston, and Thai forest. Lab results revealed a 5th species, hidden in the wild for centuries. They named it Bundibugyo. Human expansion into the jungle forced this pathogen into a human population, killing 37 people before the outbreak was finally contained. The quarantine was lifted, the news cycle moved on, and much of the world assumed the threat had been permanently neutralized. This WHO map tracks the history of these outbreaks, highlighting the 2012 return of the virus. This time it struck the Democratic Republic of Congo with an aggressive mutation, killing 47% of those infected. This flowchart illustrates the natural reservoir, the animal species where a virus hides between outbreaks. Identifying this host is the only way to predict future spills. Despite years of research, the reservoir for Bundibugyo has never been found. Without identifying the host, the virus remains undefeated. It continues to circulate in an unknown animal, waiting for the next point of human contact. This is the World Health Organization headquarters, where Bundibugyo is currently categorized as a priority pathogen because its origins remain unknown. The jump from an animal host to a human, known as zoonotic spillover, occurs as a direct consequence of human expansion into wild territories. As industrial logging, mining, and farming carve into untouched ecosystems, they strip away the physical buffers that once separated human populations from unknown wildlife. This ongoing ecological destruction provides ancient pathogens with constant access to new, highly mobile human hosts. The real risk lies in the math of future outbreaks. If a lethal virus with an unidentified host undergoes an airborne mutation, the timeline for a global crisis accelerates. An infected person at a remote site can reach a regional city and board a commercial flight in less than a day. This sign represents the point where an incurable pathogen enters the global transit system. The global community is still managing the consequences of COVID-19. A similar transmission event involving a virus with a 47% mortality rate would result in a significantly different outcome. Agnes and the Bundibugyo virus prove that a reactive strategy is insufficient for modern threats. Security depends on respecting ecological boundaries and funding proactive vaccine research before the next spillover occurs.